There are two types of people in the world. There's the Scots and those that want to be. William Smith's great contribution to geology was his publication of a geologic map of the British Isles and its accompanying stratigraphic column. His mapping methods involved the use of fossils and stratigraphic correlation. His techniques would inspire younger geologists from all around the world to map their own countries and to construct a world stratigraphic column and eventually the modern geologic timescale. Yet his map of the British Isles was not complete. The top of the map shows only the southern parts of the Scottish Highlands. The northern tip of Scotland and the islands further to the north were omitted. There were reasons for this. The Scottish Highlands were tough, snowbound mountain ranges that are dangerous even today. Even worse, there were no shelly fossils in the most ancient rocks, and metamorphic changes by heat and pressure frequently made the original rock layers unrecognisable. So Smith's usual correlation methods had broken down. You have probably realised by now that Great Britain's oldest rocks are found in Bonnie, Scotland. Smith mapped what he could and placed them as his oldest layer at the base of his column. Geology flourishes when curious scientists develop new insights. One such individual was the German doctor, chemist and geologist Johann Lehmann, who did his best work in the 1750s. Believing that the oldest rock layers were at the bottom and the youngest at the top, he mapped 30 rock strata in his native Saxony. So Lehmann was one of the fathers of modern stratigraphy. He formed the view that all of his rocks were formed under the sea. We call him a Neptunist geologist, after King Neptune, the old Roman god of the sea. Lehmann died suddenly when a retort full of molten arsenic exploded in his face. His ideas were adopted and developed further by another German geologist, Abraham Werner. Werner taught mining and mineralogy at the Freiburg Mining Academy. He built up a wonderful mineral collection. His picture reveals the face of a kind and charismatic teacher who attracted eager students from all over Europe. Suffering from poor health, Werner did little field work, and this was one of the reasons why his theories were seriously in error. The Germans were vaguely aware that volcanoes existed, but put them down as minor events caused by burning coal seams. When they melted rocks and ores in their foundries, they produced glasses without well-formed crystals. But it was quite easy to produce big crystals in a laboratory by chemical precipitation or evaporation. So the crystals found in all rocks were formed under a giant ocean that covered the planet and gradually receded with time. Smith's granites and gneisses were sedimentary rocks, as was basalt, and the earth was young. Between 1783 and 1784, a major event occurred which caused Scottish and European geologists to question Neptunus theory. Iceland is the land of fire and ice, and sits astride the mid-Atlantic ridge northwest of the British Isles. It is a place where new crust is forming by volcanic action as the North American plate moves west and the Eurasian plate moves east. So Iceland has a number of north-south rift valleys and cracks or fissures where it is not a good idea to build a house. In 1783, the Laki fissure erupted massively from 130 volcanic craters for 8 months, producing lava fountains up to 4,600 feet high. The presence of glacial ice made it explosive. So 14 cubic kilometres of basalt flowed out, and a cubic kilometre of ash blasted up and headed around the world together with over 100 megatons of poison gases, mostly sulphur dioxide. Covered with ash, Iceland lost half its animals, all its crops, and a quarter of its humans by starvation or volcanic action. The northern hemisphere was visited by a poisonous haze which blotted out a rust-coloured sun and triggered savage winters that caused crop failures and starvation. There was famine in Africa, Egypt, Japan, India, Europe and England. It is estimated that 2 million people died. Within 5 years, the unhappy French peasants began bloody revolution. Meanwhile, on the other side of the Atlantic, American revolutionary and scientist Benjamin Franklin was commenting on the smog and the terrible, terrible cold. The early Plutonist school of geology gradually emerged to challenge Werner's Neptunism. It was named after the old Roman god Pluto, who ruled the underworld and, like the old Greek and Roman deities, was a particularly nasty piece of works. The Plutonists believed that the Earth was a source of underground heat, and that this heat caused rocks to melt, forming volcanic rocks such as basalt and plutonic rocks such as granite. The heat was also an energy source for Earth movements and caused the change or metamorphism of rocks by heat and pressure. One pioneering Plutonist was Christian Leopold von Buch, who studied under Werner at Freiburg in 1793. He was everything that Werner was not, a world-travelling man of boots, maps and hammers. In 1802, he explored Le Massif Central area in the Auvergne district of France. This is my sample of recent lava from that area. The region is littered with trachyte plugs from extinct volcanoes and basalt lava flows that occur in layers. This is the Puy de Dôme, with a castle on top made of six-sided basalt columns. The highest peak is the Puy de Sancy. He dutifully made a description and outlined how they formed under the ocean. In 1805, he observed Mount Vesuvius erupt, and that caused him to do a total rethink. He then correctly described many different volcanic areas. The Canary Islands, off the coast of Africa, were obviously volcanic. He then proceeded to the coast of Scotland and Antrim in Ireland with its famous Giant's Causeway of six-sided basalt columns. This other structure in Scotland is caused by a petrified tree stump that got itself caught in the lava. He finally published a geologic map of Germany in 1832. The ancient hill fortress of Edinburgh Castle sits on top of a Carboniferous volcanic plug 350 million years old. Nearby is the old Scottish University of Edinburgh, which remains one of the most prestigious universities in the world. It was admirably positioned for its scholars to solve the sequence of Great Britain's oldest rocks. In Smith's time, it had a professor of geology, Robert Jamieson, and he was an ardent Neptunist. It was time for the appearance of a revolutionary scholar with a nose for sniffing out the Earth's secrets. Born in 1726, James Hutton was one of those scientific geniuses that pop up from time to time and change the world. Hutton studied at 3 universities, Edinburgh, Paris and Leiden, where he graduated Doctor of Medicine. But Hutton had one of those restless minds that drove him to explore many branches of science. In partnership with James Davy, he developed a technology for recovering ammonium chloride from soot. He owned property and developed new farm management techniques and ways of animal breeding. His farms, his involvement in canal building, and his house overlooking Salisbury Crags led him to explore the rocks of Scotland and to develop a number of ideas that would revolutionise geology for those who continue to research Scotland's oldest rocks. His writings were presented to the Royal Society of Edinburgh, and do waffle on. But by the time his successor, Sir Charles Lyell, published his Principles of Geology in 1830, we see all of Hutton's ideas presented diagrammatically and simply. It's all there. The granite batholiths, the metamorphic rocks that have been changed by heat and pressure, the volcanoes, the sedimentary rocks, and the volcanic dike. The geological structure of Scotland reveals itself when viewed from space. There are 4 main blocks of crust that have welded themselves together. Each block contains a variety of rocks of different ages that formed in different ways. The Midland Valley is a graben that sank and filled with sediment and was intruded by volcanic rocks. This is where the Scottish lowlanders live, with the best farmland and the coastal city of Edinburgh. The other 3 blocks are upland areas. To the north of the lowlands are the 2 highland blocks which contain most of the Precambrian bits and pieces. The faults between the blocks are most interesting. They are marked by linear locks or lakes, long straight rivers, and the abrupt rise of formidable cliffs. James Hutton had his own geologic method. It was called uniformitarianism. Simply stated, it claimed that the present is the key to the past. To study old rocks, you study how rocks are forming now. To study volcanic rocks, you study volcanoes. It did not take him long to recognise that the Salisbury Crags overlooking Edinburgh were the remains of a volcanic dolerite sill that spread out between older rock layers in the past. Hadrian's Wall, built 5 metres high by the Romans to keep out the Scots, was situated on the Great Windsill to the south, together with some castles. Wall-like dikes were also formed by magma intruding vertical cracks and solidifying. They were not sedimentary structures. But there were also other igneous rocks with bigger crystals, such as granite, to be explained. Whilst examining highland rocks, he found granite veins obviously intruding metamorphic rocks such as schist and gneiss. He reasoned that granite was an igneous rock that cooled from molten magma. He also believed that the granite had altered the rocks that it had intruded. It had metamorphosed or changed the rocks by heat and pressure. We now know that granites are the product of mountain building activities where older rocks are buried deep below mountain chains. Metamorphic rocks are produced with new minerals by heat and pressure over time. Sometimes partial melting occurs and granite magma forms. It can happen on a large scale, forming huge masses of rock that we call batholiths. These particular mountains here are of granite and its related plutonic rocks. We have never drilled to the base of a granite batholith. Hutton's theories had allowed Scottish geologists to distinguish between sedimentary, metamorphic, volcanic and plutonic rocks in the highland areas. But there was one insight yet to come. Visiting the east coast of Scotland with his friend Sir John Playfair, Hutton found an unusual contact between the Upper Devonian Old Red Sandstone on top and a lower Silurian tilted grey sandstone on the bottom. So what was that all about? We call this structure an angular unconformity. The older grey rock sediments were originally deposited flat underwater. Then they formed solid rock, which was tilted over time in a mountain building event, before being worn down and covered by the younger reddish flat sediment. Hutton formed the view that such a process required lots of geological time, and that the Earth could be older than previously believed. But he had no way of knowing how old. Unconformities are geologically significant. In these examples, see if you can work out the line of the unconformity, the line which indicates the old eroded land surface. First, in France, Triassic on Cambrian. Second, Missouri, in the US of A, Cambrian on Precambrian. Third, Somerset in England, Jurassic on Carboniferous. Fourth, Jiangsu, China. And finally, our very own Canangra Walls, Blue Mountains, where flat-lying Permian and Triassic Sydney Basin rocks rest on tilted Devonian metamorphic rocks. We move to the oldest rocks in the Scottish Highlands. Often sitting on the hilltops is a white metamorphosed Cambrian sandstone called a quartzite. It contains worm track fossils and is around 500 million years old. Below it is an unconformity, and then the reddish-brown Proterozoic sandstones, which are up to 2.5 kilometres thick. They date between 800 and 1200 million years old. The locals call them the Torridonian group, and they mark the top of the British Precambrian. Below that we have a major unconformity, and the rocks below that are highly metamorphosed gneisses which are often intruded by granites. They are Archean in age and correlate with similar rocks in Norway, the north of Ireland, and even Canada and Greenland. Aussie technology using zircons is being used to help date them, and they may be up to 3,000 million years old. The oldest rocks known are gneisses in Canada, dating 4,100 million years. The oldest known earth crystal is an Aussie zircon and dates 4,404 million years old. Australia has lots of Precambrian rocks. Here my daughter is visiting one of them, an Archean wind-blasted ancient granite in West Australia called Wave Rock. It is over 2.5 billion years old. So whatever happened to William Smith, who, like Charles Dickens' family, had been traumatised by being thrown into debtor's prison? The Geological Society of London was the most prestigious of its type in the world. Its members were a mixture of Anglican clergy and a new breed of researchers and mining engineers. They began to share a common purpose to right the wrongs done to the old pioneer of stratigraphy. In 1831, Smith was summoned to this building at Oxford University to receive the inaugural award of the Wollaston Medal, the Nobel Prize of Geology at the time, and full membership of the Society. Professor Adam Sedgwick referred to him as the father of English geology. Further honours followed: Doctor of Laws from Trinity College, Dublin, a life pension from the King, and a nice farmhouse to live in near Scarborough on a very cheap rental. This museum was built in his honour. He even designed it himself. At long last, the old seer and risk-taker was finally on the up.